Alright, y'all, so check it out. We got here ESP32-C6. We got a battery, 3.7 volt, 1200 milliamp hour, MCP 9808, SCD41, CO2 sensor, temp sensor, controller, battery. I need to add a switch. I'm gonna add a toggle switch, and then I'm gonna have to solder LED on here. So we'll have a single LED that will give indication of the rough air quality coming from the CO2. And the temp sensor is going to be pretty much isolated. So the goal is the SCD41 is very susceptible to drafts and wind. And so if you look at this diagram, this is basically the diagram from the sensor maker, Sensoron or something like that. But basically, the manufacturer put out a document. I can link to the PDF, but in the document there's design specifications that go over when designing an enclosure, and so you have to take these specifications into account when doing different designs. So for example, like this is another one of my builds, custom builds, and this has a toggle switch on the side, that there, and then screen interface slotted. And so with this other design, I'm using different sensors that are not as susceptible to the forces and the vibrations and everything like that. So this sensor is super sensitive because it's a highly sensitive instrument, and so because of that, it has to be treated accordingly and as such. So the biggest thing with these sensors is that you have to kind of keep in mind vibration. I actually had a previous project with another vibration sensor that ended up getting dropped, and it got dropped hard onto like concrete, maybe like 4 to 6 feet, and after that it no longer worked. And so since then I've been keeping in mind of, okay, this is not only something that is sensitive, it's a highly tuned instrument, but if it has the right protections, because before I just had the sensor like mounted straight onto the body, which, just knowing anything about vibration, dampening forces, and it was just not ideal. And a lot of the design, but again, this is how we learn, right? We learn through the failures and the mistakes. So each one of those has taught me something. And so with this design, I just got it strapped down to the cardboard. I just did the calibration outside. It has a self-calibration, the SCD41, and when I took it outside, it dropped to, I think the lowest was like 389. And so with that, that's about pretty good. I think outside is supposed to be like around 400 or so. And so, yeah, so it dropped pretty low. It did its thing. It calibrated. So it has like that low point at least. And they say, I think, I gotta go back over the manual, but they say to take it out, I think maybe at least once a week, kind of get it some fresh air so that it can recalibrate and get that, basically that low end, jumping again. But yeah, I mean, all things considered, actually, you know, I was thinking about, I don't know, this still probably be easier. It'd be easier to solder just a single, because this is just these are just 3mm LEDs, so they're not that big of a deal. Like, it's literally just a ground and a power, and they're pre-wired, so it already has a resistor in there as well, which these are nice. They cost a little bit more, but I find it's worth it just for saving time and not having to wire a resistor on every single LED, etc. But yeah, so right now I've got the iOS app built, and the iOS app is pretty straightforward. It's I've got content view, so I've got the sensor manager, and this is basically going through and setting up all the services. And then you got your basic, so we're just initializing the model container for Swift data. And then the reading card is just a basic card with the title and the value. So it takes in a title and it takes in a value. And then with that, it formats it using SF mono, which is crucial for numeric text transition, which is one I really like because it's a smooth transition with the number values. So with that, we now have the reading history view, and again, pretty simple, straightforward, just boom, boom, boom. I just got, scrapped something together real quick just to get off the ground. And so the values we're storing are the CO2, humidity, temperature, and timestamp. So those are there. And then this is the sensor reading view. And so again, we're just taking the card we created, and then we're passing in the temperature and then the value. And then we're passing in the humidity, the value, and then we're passing in CO2. And so on the Arduino side of things, that looks like as well. I'll show you what that looks like. So we're creating the sensor objects, doing error handling, the BLE, and I'll link to all this code because, I don't expect you to try to read it from here, but just so you can kind of see what I'm talking about. But we're setting up the server, the Bluetooth server, BLE server, characteristics. So we've got the temperature characteristic, we've got the humidity characteristic, and then the CO2 characteristic. So when you think about BLE, basically it's just like each characteristic allows you to create like a section, a partition of data, right? And so once you set up this server, then on void disconnect, pretty basic setup. So we're initializing I2C since we are connected using the quick cable, which these are super awesome for, again, rapid prototyping, because instead of, I would have had to solder all these, just plug in, boom, and I only now have to solder 2 connections instead of what would have been 8 or more. Yeah, something like that. So so that runs through that. You got your device name here, initialize BLE, NeoSense, and goes through, creates our characteristics. Those are the characteristics we talked about at the top. And then adds descriptions. So boom, we add that there. Then we do the advertising. Couple functions, help with the connection. Boom, 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 boom. Then here's the money. All right, read from the MCP. Average temperature. So we take the SCD41 temp and the MCP, because the SCD41, it has the sensor on board can create fluctuations in the temperature reading. So it can, because it has like self-heating, it can influence the temperature readings. So I wanted to get an isolated temperature sensor that was going to be separate. That way I could get more accurate temperature readings and basically weigh this one more heavily, but also kind of double correlate it with the readings coming off the SCD41, since the data is available. But it's like, I'm gonna make this 20%, and I'm gonna weigh this 80% because this is a highly accurate sensor, the MCP9808. So with that, I'm just going to allow it to do its thing. When I designed the enclosure, I kind of have some, I was playing around with a little bit of designs, but nothing too serious. Okay, so yeah, so here this is. So here's what I was thinking. The type C cable, whoops, that's got to come down. I got to drag that down -2 millimeters because I moved the whole thing. Let's see if I can click with the, oh no, I clicked the wrong one. Oh. Try to do it with one hand. G, we're going down on the y-axis. Oh, nope. There we go. See. Okay, -5 maybe? Yeah, that looks about right. Alright. So, what I wanted to... Oh, wait a minute. That thing look way bigger than it need to be. Alright. Oh, that's right, because the thing is for the fitment. Okay. So when I did a fitment test on this. Basically, I have this piece here, which is inside. It's just fitted for the USB, so I could see how far the USB-C cable would go in. And I fitted it for the Apple USB-C woven cable. So basically it would, let me turn off the curves, makes it a little easier to see. And let's turn off X-ray mode. Okay. Alright, that should make it a little bit easier. Okay, so here's kind of what I was thinking initially, but of course this is not going to work because, well, I have to put up some walls pretty much, but I would have to put up a wall divider here, and then I would have a small, almost like a small slit, maybe about 3 vertical slits that would allow the air to penetrate but not directly affect the sensor. And so this would be the SCD41, and then off to the left side would be the MCP9808, and that would be in its own room as well, quartered off. And then with that quartered off room on the bottom, so this would like be the second floor, which is kind of hard to visualize, but we'll have 2 floors. And I'll turn off the main outer shell, but we'll have 2 floors. The bottom base floor is going to be where the battery will slide in, so it'll almost be like a slot, and then the battery will slide in, and then the leads will come out through the back. There'll be a cut back here, and the wire will go through here. So this wire connected, it has it here in the middle, but it's off to the side, but it's fine. But it will come through here, and then it's got to plug in here on the board. And so battery gets connected here. That's on the bottom first floor. And then we'll have the, let me put the side view. So we'll have the platform, and then that's where we'll start to section off and corner the rooms. And the LED, that's the 3mm LEDs, these guys. So that's real small as well, so I'm gonna have to design like an enclosure where it'll just kind of clip in, and then I'll solder those leads onto there. And then everything else, the stemma QT, that's gonna go from here to here, and then probably, see, this is where we get into the tightness, because I'm gonna have to figure out a way to route those stemma QT cables probably along. I'll have to maybe make a channel in the floor or the subfloor, so that way maybe I'll create a subflooring that I can just easily snap a panel and cover it. That way there will still be that separation, but essentially I'm going to create the walls that will isolate it, that will isolate each section, so that way the board is probably give it a little bit more spacing, space it out just a little bit. I still want the device to have a compact footprint, but this is the Zhao board, the ESP32s. I'm trying to find something better for a frame of reference, but like maybe this alcohol prep pad. So I mean, it's quite small, so even the battery in itself, pretty small. The SCD41, pretty small. But if we stack it up, keep it pretty compact, I would like to keep it compact. I just want to allow for proper dissipation of force and plan ahead in regards to that. But if we can manage the design in a way, because also what I wanted to do is integrate the design to where the cable is like plugged in and flush. So kind of how the home pods have, it looks like on the back. Let me put a home pod plug. So kind of like the, okay, boom. So like that's what I'm talking about. So I kind of want the design to look like that, to where it looks seamless, like as if it was part of it. So that's kind of why I designed the shell initially like this, to where it has this curve, and so it will take the cable all the way in and then just look flush. So from the side you wouldn't see it like plugged in, if that makes sense. It'll just look like boom. All right. And so this would be the on and off switch, the on and off toggle switch. And then this would be the indicator LED. So the device could essentially sit upright like this and just be here. And then on the back cover, right where the SCD is, that will have the slots to allow for the air to penetrate, and then the same thing for the chamber, but each will be its own separate chamber. So we'll have like a left chamber and a right chamber, and then those will be sealed with the top that will basically keep that section separate, and this section separate, as well as the bottom. So then we'll have that tiered layer system, and we'll be able to basically stack. And I think if we plan accordingly, like if I give myself enough spacing here to ensure that like the connectors, because sometimes if you look at the depth of the connectors, that depth can end up being, with the connector plugged in, it ends up being a lot wider than anticipated. And you got to think about the bend of that cable, because if you press it up against that casing, the cable is going to be bent at a 90-degree angle or so, and that's not good for the cables to be bent at such an extreme angle. Now the good or kind of saving grace is like if it's not going to be moving that much, you know, that's kind of better. But ideally you wouldn't want it to have such a harsh bend. So if you can at least kind of get it to a more natural bend, that would be ideal. But just kind of based on the placement of the plug and the terminals, it's like you pretty much have to give yourself that margin on the side, because otherwise, like this one on the top is awesome because that vertical, I can just, that's going to be a nice smooth bend, and then, you know, it can go through the channels. But the side one is going to be a little bit more difficult, just because we have to ensure that we give ourselves enough spacing here on this side axis. But essentially this is what the casing would look like. I kind of like it because it's kind of almost like a pager piano type of vibe, and I'm feeling like if maybe cut out some like surface, round it out, do some like fillets and some almost like some laser etching type of markings on the surface. That could be really cool, and then give it like some really cool texture, some like different cutouts, just make it look like more sci-fi almost. But yeah, in essence it would look something, let me get rid of that back view. Okay, so it would look something like this plugged in. Which I'm not mad at that. I'm not mad at that. Cause yeah, I mean, I'm trying to think, because I want it to be like something I could clip onto a backpack and take, like just portable, just to see levels and stuff when traveling or just out and about. But in order to do that, I'm gonna have to figure out a way to integrate the clip, or a clip like a carabiner clip or something like that, or a way to mount it, or figure out some aspect of that. So I'll have to take that into consideration with the design as well. This is just something I very quickly threw together as a V1, just kind of playing with layouts and concepts. But sometimes, and what I'll probably do is actually test out some rapid fire designs with cardboard. Like this I just did to get the sensor calibrated and just to get it outside, that way the air wasn't hitting it directly or nothing. But yeah, ideally, if I can get everything as compact as possible while giving it enough spacing that it doesn't get affected by the heating from the ESP32 or the battery or anything, you know, nothing. That way everything is basically segmented as possible with the appropriate ventilation, and allowing for the channels to do their thing. And pretty much the biggest thing I'm designing for is the SCD41. So that's the priority device, so I'm designing for that first and foremost. I actually got a custom so we got some M2 screws, some brass fittings as well. Oh no. Oh, not glue gun. All right, silicone. I got some silicone to make some custom molds. I was gonna 3D print some custom bushings and like a custom honeycomb lattice structure that I can lace at the bottom of the sensor that would give it a suspension. So it'd be like a honeycomb suspension that could dampen the force. And then I was going to print out some TPU bushings that could go around the column that the board would get mounted into, so that would kind of act as a spring, and then so that way it didn't bottom out, it would have the honeycomb lattice structure underneath that would then give it the extra support. So it would have the TPU bushing, the honeycomb, and then the brass insert, and then the screw would go through all of those to get to the bottom of the casing. So once I figure out the layout stuff, we'll be rocking. Right now, at least I confirmed everything's working. It's active. I've got the iOS app talking to each other. So from here, I'm gonna make it look better, improve the UI, and clean up a few things. But I've confirmed the functionality, and so that's the green light on that, and everything is working. So we're gonna do the case design and do green light on that. Shout out to Adafruit, super quick shipping. I never have any issues with any of their sensors. Their stuff is amazing, like just worth it every single time. This is my first feather board, definitely will not be my last. I've had other similar like ESP32 boards, but I was actually really shocked at how small this was, and even came with the NeoPixel. It's got the battery charging and the actual monitoring, which I need to set that up, matter of fact, because it's got the, I think it's a Max 1708. It would be, oh, it's not gonna, it would be this, that little guy there. But the yeah, I'll have to get that set up. Max 1708 battery. Let's see. Boom. Yeah. Oh, 17040. Yeah, that shit looks. Boom. That's a little dude right there. Yeah, so with that, we will follow up with the casing and the rest of the design. I will put some footage of the iOS app just in action, doing its thing, and its V1 stage, and then when I follow up with the video, I'll show you what changes I made and how I jazzed it up. All right, to the next time. Peace.